Swayam Prabha. Digital India. Educated India.
Hello everyone and welcome back once again. So right now our topic of discussion is metal matrix composites, and with regard to that we have been discussing about aluminum based metal matrix composites in past few lectures. So far we have seen what kind of materials are used as the reinforcement in this kind of composites, and we have seen what kind of processes are used to add these reinforcements into the metal, and these processes can be a solid state process, a liquid state process, or a two-phase processing route. So, we have discussed in detail these processing routes as to how the process is carried out and different other aspects of such processes. And then we have also seen what is called an in situ composite. Okay. So, in such composites known as in situ composites, the reinforcement is generated in situ during the processing itself, unlike the conventional metal matrix composites in which the reinforcement is added externally. Okay. But in case of in situ particles, as we have seen in the previous lectures, the reinforcement is generated in situ during the processing itself. Okay. And we have seen what kind of process can be used to generate such in situ reinforcement during the processing. Okay. However, in most of the cases the reinforcement particles are added externally. So, there are two things which are to be considered with regard to that. One is weighting of the particles by the metal. When you add these particles into the liquid melt, whether the surface of the solid particles is weighted by the liquid or not, that is very important, okay? Because that is going to decide whether a bond between the particles and the metal will form or not. Okay, so that's one thing. And secondly, how the particles will be distributed when they are taken into the molten metal. Okay. So these two aspects are very important for getting a good quality composite. If you do not have weighting, you do not have bonding, and particles will be rejected and they will either float or settle down, and they will not go into the metal and make a bond with the metallic matrix. Okay. And particle distribution is also very important, because if there is agglomeration or clustering of particles, that would affect the properties adversely. So we need a composite where there will be good bonding between the particles and the matrix, and the particles will be uniformly distributed. Then only you can expect to get all the advantages of a composite material, such as high strength, high hardness, wear resistance, and so on. Okay. So in order to ensure that you have weighting, you will have to look at the process parameters. And with regard to weighting, you will have to go back to this particular diagram again, where we have a solid surface which is coming in contact with the liquid. So let's say this is the liquid drop which is sitting on a solid surface. So how good will be the weighting between the liquid and this solid surface? That would be decided by this angle, which is known as the contact angle. And what will decide the contact angle? The contact angle will be decided by the surface energies. The solid liquid surface energy, the liquid vapor surface energy, and the solid vapor surface energy. So if you take a balance of forces, you can derive the contact angle from that. Okay. So for a good weighting to happen, theta should be small. First of all, it should be less than 90 degree, and lower the theta, better will be the weighting. So this is the first requirement for a bond between the particle and the metal to form. Okay, unless and until the liquid weights the solid particle surface, the bond between them will not form. Okay, and in order to ensure a good bonding, the contact angle has to be less than 90 degree. So when you select a reinforcement material, this is also one aspect which has to be looked at as to what kind of material you are talking about and what will be the contact angle of that material with liquid aluminium. Okay. So nowadays there are instruments through which you can put a drop of molten aluminium on a solid surface and you can actually measure the contact angle, right? So you have to evaluate that also while selecting a particular reinforcement for making aluminium based metal matrix composites. So our objective is to have a low contact angle, okay? And if there are ceramic materials which are not good in terms of weighting with liquid aluminium because the contact angle is not low enough, okay? So if you have a material like that, I mean, if there is a need to add that ceramic material, okay, but you know that the contact angle may not be low enough for a good weighting to happen, then something has to be done to modify the surface of the ceramic phase of the reinforcement phase so that you can modify the surface energies in a way which will decrease the theta or increase cos theta, okay. For example, if you can decrease this surface tension of the liquid, that is gamma LV, then theta will decrease. Similarly, if you have a high value for this solid liquid interfacial energy, that will also give rise to a low theta, right? So it tells you that if you can modify this solid liquid interface, that is the surface of the solid, you can actually improve upon the contact angle for a better weighting to happen. Okay, so there are certain methods by which it can be done. So let us have a look at those. This is what just now we discussed. Okay, this contact angle should be as low as possible. Okay, and as I said, it depends on the surface energies. So in order to modify the surface or the surface energies, you can add weighting agents. So these are basically elements or compounds which can be added to the molten metal for modifying the surface so that the surface energy can be altered towards decreasing theta. Magnesium addition, for example, in aluminium can do this job. It can modify the surface energies in a way which will decrease theta. And as I said, you might have a ceramic surface which is not good for weighting with liquid aluminium, and therefore if you add those kind of ceramic material, chances are bonding will not be good. Okay, so you will have to modify the surface and make it conducive for aluminium to weight it. Okay, so if you could coat that ceramic surface with another metal which has good weightability with aluminium, then there will be good bonding. So you can have a very thin coating of a metal like nickel on ceramic particles, and this will ensure that the bonding between the particles and aluminium is good, because now the bonding will take place through nickel and not directly through the surface of the ceramic particles. When you add silicon carbide as the reinforcement, then you can also give it a heat treatment at a certain temperature at which silicon can get oxidized and form a thin coating of silicon dioxide over silicon carbide particles. Okay, and in terms of the weighting, silicon dioxide is much better compared to silicon carbide. So if you form a coating of SiO2 on silicon carbide particles, you can improve upon the weighting, or you can decrease the contact angle. Okay, and these are some of the experimental results in which people have shown the effect of temperature and its correlation with the contact angle. So when you talk about weighting of a solid surface by the molten aluminium, there are basically three stages of this whole process as to how the solid surface is weighted by the liquid and leads to a bonding. Okay, so these are the three stages of that. First, deoxidation of the aluminium surface by molten aluminium, which is something like this. Aluminium is prone to oxidation, so when the reinforcement is added, chances are fresh aluminium surface will not come in contact with the reinforcement. Rather, there will be a layer of aluminium oxide, and this will prevent the bonding between the ceramic reinforcement and the aluminium metal. Okay, so in order to have a good bonding or good weighting, this oxide layer has to be broken. Okay, so that is the first step, the deoxidation of the aluminium surface or removal of the oxide layer, so that a fresh aluminium surface can be presented to the reinforcement for the bonding to happen. Okay, and then if you have a material like silicon carbide, Then it also goes through a deoxidation process on the surface, which will disrupt any oxide layer that may be present on the surface of the particles. Okay, so this will also ensure that a fresh silicon carbide surface is presented to a fresh aluminium surface, and that is good for bonding. And then you can also have weighting through formation of an interfacial layer of some product, okay, of some reaction product. So you first let the matrix metal and the reinforcement react and form a reaction product, a very thin layer of this reaction product along the interface, and this will actually lead to a good bonding, provided this is very thin and does not extend into the material. Okay, if it grows and extends further away from the interface into the material, then this will grow as a reaction product, and since this kind of compounds are brittle, it will not be good for the properties of the material. So the formation of this has to be limited only at the interface. Okay, so if this kind of interfacial reaction products are present, then it will actually lead to a good bonding because it will improve the weightability. And formation of such interfacial reaction products is influenced by alloying additions such as silicon, which can actually suppress it. So if you want to prevent the large scale formation of aluminum carbides, and you want them only to be restricted as a thin layer along the interface, then silicon is an alloying element which can be added to prevent the formation of aluminum carbide as a reaction product rather than as a thin interfacial layer. Okay, and silicon also improves the weightability by segregating at the interface and forming strong chemical bond with silicon carbide. So here, instead of forming a bond between silicon carbide, which is a ceramic material, to a metal like aluminum, you form the bond with the help of silicon in between. And silicon being a metal or close to a metal will give rise to a better bonding compared to when you have silicon carbide as the bonding surface. Okay. This is an image which shows how this aluminum carbide layer forms along the interface. So this is the interface between silicon carbide and aluminum, and this is how the aluminum carbide interfacial layer forms. And you can also see the effect of processing temperature over here. When you increase the temperature, you can see how the contact angle is influenced. Okay. So higher the temperature, lower is the contact angle, but after a certain time, it kind of stabilizes, as you could see from these plots. And metal coating on the ceramic particles, which I was mentioning before, would actually form a layer of a reaction product like this. For example, if you have nickel coating on a ceramic particle surface, it will react with the aluminum and form this kind of intermetallic layer on the surface of the ceramic particles. And through such interfacial layers, the bonding will now happen because this kind of interfacial reaction product on the surface of the ceramic particles will actually decrease the contact angle. Okay, so that is what is being shown over here. If you could have a look, this is a contact angle of a droplet of aluminum on aluminum oxide, and when you have the presence of nickel, that means this is a nickel coated aluminum oxide surface, you can see how drastically the contact angle reduces from more than 90 to less than 15 degree. Okay, so that is how the surface of the ceramic particles can be modified with the help of a metallic coating which will reduce the contact angle. And this reaction is also exothermic in nature, so this will ensure that the oxide layers from the surface are also removed. And if you have such coatings, such metal coatings, it will also prevent the formation of this kind of carbides, which may be detrimental. Okay. Some additions into the molten metal can also do the same job of improving the weighting. Magnesium addition, for example, can reduce the surface tension of aluminium and alter the solid liquid interfacial energy in a way that will reduce the contact angle and it will lead to a better weighting. Okay. So what happens when you add magnesium into molten aluminium in small quantities? Magnesium will basically disrupt the oxide film on the aluminium surface, and as a result of that it will lower the contact angle. Okay. Titanium addition can also be done. So in that case, titanium addition leads to absorption of titanium and formation of titanium carbide when you have silicon carbide as the reinforcement. And titanium carbide has a much better weightability with aluminium compared to silicon carbide. So if you have an interfacial layer of titanium carbide, there will be a good bonding between aluminium and silicon carbide. And silicon addition, on the other hand, works in the way that silicon will get absorbed on the silicon carbide interface and improve the weighting by forming strong chemical bond with silicon carbide. So this I said before also that silicon will actually segregate along the interface between silicon carbide and aluminium, and with the help of this silicon which is now present along the interface, the bonding will take place. Okay. So with the additions of metals like this, magnesium, titanium, silicon into aluminium, the weighting and the bonding can be improved. This is an image which shows you what kind of bonding we are talking about. So this is the finally formed composite material. This is after the solidification, the composite has been made and then a sample has been collected from that and it is polished and a micrograph is taken in the scanning electron microscope. So this is the silicon carbide particle, the left hand side, and the right hand side is the aluminium matrix. So this is the kind of bond that we expect to form between any reinforcement and the metallic matrix. Okay, so only when you have a bonding like this you can expect better properties in the composite. Otherwise, even if you have these particles added to the metal, you may not have better properties, rather you might have inferior properties compared to the monolithic metal. An example is shown over here where you can see the particle is added and it is actually gone into the material, into the metal, but the bonding, the interfacial bonding is not good because you can see the cracks along the interface. Okay. So even if you have the presence of particles in a composite like this where the interfacial bonding is not good, the properties are not going to improve. Rather, they might even go down. They might even be inferior compared to the unreinforced metal. Okay. So that is what I mentioned in the beginning, that one of the most important aspects that you need to look at for having good properties in metal matrix composite is the bonding between the particles and the matrix, and this will depend on the weighting, and the weighting will depend on the surface energies, and at times you can control that by controlling the process parameters such as the temperature. Okay. So let me quickly summarize what we discussed today. Today we discussed a very important aspect of metal matrix composite, that is the bonding between the reinforcement and the metallic matrix. So this essentially depends on the contact angle or the surface energies. So the surface condition of the reinforcement will play a major role here when you talk about the bonding between the reinforcement and the metal. Okay, so you have to have a surface condition which will lead to a low contact angle, and then only you can expect a good weighting to happen, and only when a good weighting happens you can expect to have a good bonding between the reinforcement and the metal. Okay, so there are certain things which can be done to improve the weighting between the reinforcement and the metal. These are metal coatings. A metal can be coated over the ceramic particles, and since metals will have better weightability with aluminium, this will improve the bonding between the ceramic particles and the metallic matrix. Okay, then you can also have additions of some metals such as magnesium, titanium and silicon. This will also modify the conditions in a way which will lead to a low contact angle and therefore a better weighting. Okay, so it can be either through the modification of the surface by disrupting the surface film, for example, or there can be metals which can actually segregate to the interface and lead to a good bonding between the metallic matrix and the ceramic reinforcement. It can even react with the ceramic reinforcement and form another ceramic, like for example titanium carbide, which has a better weightability, and therefore this will lead to a better bonding. Okay, so these are some of the ways of improving the bonding between the ceramic reinforcement and metallic matrix, and our objective should be always to have a good bonding between the reinforcement and the matrix so that you can derive all the advantages of the composite materials and have properties which are better than both the constituents. So with that we come to the end of this lecture, but I will see you soon in the next lecture. Thank you for your attention.